Hello everyone, welcome back in the part 2 lecture of the series, that is the interior of the earth part 2. I hope you are all are very well, and in part 1 lecture we have covered the concept of such as the introduction, sources of information we have covered, direct sources, we have seen this video also. After that the indirect sources of earthquake datas and all. After that we have completed earthquake waves. What are the different types of waves, that is surface wave and body wave, we have covered. And after that we have completed earthquake waves and their basic functionality. Today we will discuss about this series part 2. I hope the homework you have done. uh, Part 2 we will start, that is the interior of the earth. In this presentation, in this video particularly, we will focus on the concept of interior of the earth, the earthquake waves, frequency, types and measurement. In this class particularly we will understand the concept of primary, secondary and their functionality. What is shadow zone, what is propagation of earthquake waves, these things we will study. Okay, so welcome back, myself Pratik Chakraborty. So let's start this concept. Okay, so when you're talking about the earthquake waves particularly, we have understood there are two types of waves. One is the surface wave and another is the body wave. So first part we will discuss about the concept of body wave. Okay, the main waves. So in body waves they are all called P and S wave, that is primary wave and secondary wave. Primary waves move faster and are the first to arrive at the surface. They are the first to arrive at the surface. These are also called primary waves. The P waves are similar to sound wave. They travel through gas, liquid and solid material. So they can travel through gas, liquid and solid material. So what is the nature of sound wave? See, in sound wave you can see two important things. One is the contraction and expansion. Contraction and expansion. So in primary wave you can see this kind of approach, that is a wave is not regular in pattern. You have a series of contraction, series of expansion, like this way. So it can passes through gaseous, liquid and solid particle. So on the other hand, S wave arrive at the surface with some time lag. That is, first P wave will originate, and when the P wave will come in the epicenter, I have told you that the when the from where the waves are generating, it is known as focus, and the first wave that hits the surface of the earth, that is the epicenter. So when the wave will come to the the epicenter and move from the surface, it will form secondary wave. They are also called secondary wave. Secondary wave, they can travel only through solid material. Remember this thing, secondary wave can travel only through solid material. This characteristics of secondary wave is quite important. It helped scientists to understand the structure of the interior of the earth. Okay, the structure of the interior of the earth. The surface waves are last to report on seismograph. These waves are more destructive. They cause displacement of rock and collapse of building. So surface wave is the most dangerous. Why surface wave is the most dangerous, I will show you through animation. Okay, so let's see what animation would like to share with us. Earthquake is going on. Okay, and if I just dissect this section and see the ground, what we can see in this image, particularly we can see the energy released, that is from the fault. Okay, and earthquake waves is generating, a series of earthquake waves are generating. So if I dissect it more, uh, the study of the earthquake waves are known as seismology particularly. Okay, so if I dissect it, so what we'll get from here, earthquake focus and the surface. I hope it was written. So let's first identify the concept of body wave of primary. First we will understand the concept of primary wave. Okay, so just see how what primary. Yes, this is the image of primary wave. I think it is visible. Okay, so if I start the animation, the flow, you can easily understand compression and expansion. Okay, this is the direction of travels. So this is primary wave. I hope it is clear. Next we having the secondary wave, and I have initially told you that secondary wave is most dangerous. Why it is dangerous? Just have a look here. Because secondary having multi-direction. Okay, they travel having a lot of directions, so it's very difficult and it's very much destructing in nature. Okay, and it passes only through solid surface, solid material. Okay, so this is all about secondary wave. So this is all about body wave. But what is about surface wave? There are two types of surface wave. First is love wave. Okay, first is love wave. It will go like this, and the second one surface wave is the Rayleigh wave. Okay, second one surface wave is the Rayleigh wave. Okay, it goes in a little bit this kind of wavy pattern, oceanic wave. Okay, like this way. So this is a general description of the waves. Next, we will study about the concept of propagation of earthquake waves. Propagation means what? Propagating means what? To move. Okay, to move. So, is their directions are fixed? First question. How they travel? What kind of vibration they generate? And these things we will study in this concept, propagation of earthquake. So, first is the movement, second is the vibration, and third is the pattern. First is the vibration, second is the movement or the direction, and third is the pattern. Different types of earthquake waves travel in different manners. As they move, they cause vibration in the body of the rocks through which they pass. Primary waves vibrate parallel to the direction of the wave. Primary waves vibrate parallel to the direction of the waves. They exert pressure on the material in the direction of propagation. So they exert pressure on the material direction of movements. For example, I'm hitting someone in front, so the pressure will be in front only. As a result, it creates a density difference in the material, leading to stretching and squeezing. That means what? Expansion and contraction. I will show the image later on. Okay. Other three waves vibrate perpendicular to the direction of propagation. The direction of vibration of S wave is perpendicular to the direction in the vertical plane. So, whenever the surface secondary waves are coming to the surface and it is distributing, it is the direction is very much perpendicular. Hence, they create trough and crest. That means ups and downs in simple language, ups and downs in the material through which they pass. So, a lot of ups and downs can disturb a general material in the surface, and hence heavy construction damages, heavy building damages takes place. Surface waves are considering to be the most damaging waves. Okay, you just can imagine the earthquake, Nepal earthquake. Okay, you can just go to Google and search all the good videos you can see about Nepal earthquake and the impact of secondary wave there. Okay, so let's understand this direction. What is propagation? What is perpendicular? What is vibration in this small video? Okay, this is all about. First, we will study about P wave. Okay, so like this way, the earthquake originating here and it is moving. This is a seismograph that I have told you, a cylindrical object that records the earthquake movement, waves movement. Okay, so let's see first the primary wave. What is the primary wave? Okay, this is the primary wave. So this is the movement of primary wave. See, expansion and contraction, expansion and contraction. Like this way, it is moving. So it impacts the material which is below the earth crust. It impacts. Okay, that is primary wave. If I say about secondary wave, you can see the movement perpendicular. It is in a bulging like this wavy movement. It can impact the construction buildings. Okay. Next, two surface waves that I have told you. Yeah, this is an example of a surface wave that is generating only in the surface. That is in the crust, lithosphere, and asthenosphere, particularly this layer. Okay, so what kind of wavy movement we can see in surface wave? This is love wave. Okay, like a snake it will go. Okay, like a snake. And this is Rayleigh waves, a circulatory, semi-circulatory manner. Okay, it will move on. So this is the four important types of waves. Two is the body wave, that is primary secondary wave, and two are the surface wave, that is love wave and Rayleigh waves. Okay. So regarding to waves, we have understood the concept of wave, the pattern of wave, the nature of wave, and which wave is more dangerous, how it is creating vibration, what is the pattern, direction, etc. We have seen. Next, we will see the emergence of shadow zone and what is the concept of shadow zone. See, earthquake waves get recorded in seismograph located at far location. However, there exist some specific areas where the waves are not reported. Such a zone is called shadow zone. Many a times what I have told you that, for example, if I take the example of a primary wave can travel through gas, liquid and solid, no issues. But secondary waves are also known as shear waves. They can only travel through solid. But as seismograph is in the surface of the earth, so many a times what happens, seismograph usually miss some records. Okay, because when earthquake used to takes place in a very big zone. So it's very difficult to take into consideration. It's very difficult from every perspective. So so how we can understand this seismic shadow zones? Just see here in this video. So whenever I'm sharing about this seismic shadow zone, you can see the black dotted lines from the in the top of this video. Wait one second. Yeah, these lines. Just a minute. I'm showing it from the first. Yeah, the red lines you can see the wave is generating, but the primary waves it getting refracted by Earth outer core, but can still travel through the liquid core. When the primary wave originates, it is penetrating the Earth's core, but many a times the wave got refracted. Hence, some shadow zones used to take place in the zone of 150 to 90 degree in this arena. Okay, these particularly are known as shadow zones. So suppose if I place a seismograph in 120 degree in both the sides, a seismograph cannot record any kind of seismic activity. It is very difficult for this. So that is one of the major issue that we used to face while understanding the concept of seismograph and while reading the data of seismograph. That is a major issue. Okay. So that's all about earthquake propagations, earthquake waves. I have told you different types of waves. See, earthquake propagation you don't need right now. Okay, the concept it's little bit for the higher classes that to analyze the degrees and all. It is not required for school. For high school, it's not required. So a basic knowledge of propagation and shadow zone, particularly, you can take. The last part we are moving is the types of earthquake. The most common types of earthquake we having is the five important types of earthquake. First is the tectonic earthquake. That means sliding of the tectonic plates. Particularly in the tectonic boundaries, we can usually identify this kind of earthquake. For example, particularly the Himalayan belt earthquake used to take place is tectonic earthquake. The earthquake is in Shiliguri, Darjeeling, Himachal Pradesh, Uttarakhand, and the entire Himalayan belt is a nature of tectonic earthquake. Next, we are having the volcanic earthquake, the Hawaiian earthquake. The Hawaiian island used to having this kind of volcanic earthquake. Next, we are having the collapse earthquake. Collapse earthquake means what? Many a times during the time of mining activity, when you are doing mining, you used to do, bomb a huge area. You have to bomb a huge area. So when you are rampantly bombing a huge area, so it creates underground pressure and sometimes it creates collapse of lot of things. That is collapse earthquake. After that, we are having explosion earthquake. That is explosion of nuclear devices, nuclear bombs. That is explosion earthquake. And lastly, we are having the reservoir induced earthquake. That is, for example, earthquake that occur in the areas of large reservoir, a huge reservoir. You can imagine. Okay, so when water is fully stored, suddenly there is a dam breaching. That is breaking of dam. it can also generate earthquake. A vibration it can also generate. So from this journey that we have started, that earthquake is only means of shaking of the earth surface. So we have traveled from shaking of the earth surface towards the vibration. So we finally just we have given the shape it more scientific. Okay. How we can measure earthquake? There are two important types of measuring technique. First, to measuring intensity. First to measuring the magnitude of the earthquake, we used to use Richter scale. Okay, to measure the magnitude of the earthquake, we used to use Richter scale. A Richter scale usually having absolute numbers between 0 to 10. So between this, we can easily determine the magnitude of the earthquake. To measure the intensity of the earthquake, that how it is much destructive in nature or something else, to measure the intensity we used to refer Mercalli scale. Okay, presently nowadays geologists and geographers used to refer modified Mercalli scale, and this scale ranges from 1 to 12. This is an example of Richter scale. You can see on the left hand side with that zigzag line, you can see seismograph reading. So if I interpret the reading, the table is there 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It is showing like this. Okay. That is Richter scale. And finally, we are having a modified Mercalli scale where you can see from 1 to 12. The division is given here. And just the side there is Richter's magnitude scale also there. And the modified intensity scale I have given here from 10 to 6 to 10. I have given it here strong, very strong, severe, violent, like this. Okay, so that is modified Mercalli scale. Okay, effects of earthquake, you all know: ground shaking, landslide, soil liquefaction, after that avalanches, ground displacement, structural collapse. These are the important things. One of the important effects of earthquake is the emergence of tsunami. You have heard about tsunami, I think. Okay, the first 6 listed things takes place upon landform only, that is ground shaking, differential ground settlement, land and mudslide, soil liquefaction, ground lurching, avalanches. These things only in landform, while the other things it based on while the others may be considered to affect the causing immediate concern of life and properties of the people. So if these things happen, for example, flood from dam failure, fire, structural collapse, falling of object, tsunami, this create a huge devastations in life and destruction. Tsunami, if I talk about tsunamis are waves generated by the tremors and not an earthquake in itself. So the concept of tsunami is little bit difficult. You cannot mix it up with earthquake. In our next lecture, we will understand the concept of tsunami. So there is a thinner difference between tsunami and earthquake. The process is a little bit same, but yeah, there is a slight difference between tsunami and earthquake. So that's all about today's lecture. Thank you so much everyone for your time. I hope you have understood the concept of primary wave, secondary wave, particularly the movement of waves and the different types of wavy movements we have understood. In the next class, we will understand the concept of uh, differential, that is landforms, volcanic eruptions, these things, and primarily there is a concept known as that yes, volcanic induced landform. That volcanism is a process. Okay, it's a dynamic process. Whatever the crust we used to see, the surface of the earth, it's constructed by volcanic eruption. The entire peninsula part of India, the Deccan Plateau, Choto Nagpur Plateau, Malwa Plateau, that you have studied in class 10, these plateaus has been constructed by volcanic eruption. So how it is doing, what are the types of volcanic mountains and all these things we will study, okay, in the next class. So I will conclude my lecture with showing you two important maps. First is the frequency of earthquake occurrence. See, the earthquake is a natural hazard. If a tremor of high magnitude takes place, it can cause heavy damage to the life and property of people. However, not all the parts of the globe necessarily experience major shocks. We shall be discussing the distribution of earthquake and volcanoes with some other details in the next chapter. Note that the quakes of the high magnitude, that is 8 plus, are quite rare. They occur once in 2.5 years, 1 or 2 years, whereas those of tiny types occur almost every minute. There is a concept known as specific ring of fire. So my suggestion is to you that go to that Google and just type Pacific Ring of Fire. You'll get a lot of things. It's a ring of active volcanoes. Every day, minute volcanic activity used to take place. I'm showing you the map of India's earthquake zone. You can easily see. I will paste it in the Google Classroom also. You can download it from there. So in this map, it is showing the intensity, the zones. The deep red zones are showing that having high intensity, high magnitude, and the white patches showing very low intensity. Okay, that is the concept of India's earthquake zone. And if you go to the world earthquake zone, the global seismic hazard, you can see the same. The deepest reddish area is the having high intensity and magnitude, and the whitish and greenish area, light green area, having lower magnitude and intensity. So as we are in India, we can say that yes, the entire northern part, northeastern part, having a prone of earthquake, because due to Himalaya, as it is also known as growing mountains, young fold mountains. So there is a possibility. That's all about this lecture today. I hope you have enjoyed the class. In the next class, we will discuss the concept of landforms and volcanoes in a different way. Thank you, everyone. Take care.